Welcome, everyone. Thanks for coming, especially on a Monday. Like, kudos to you. Basically, today we're going to go over just like general code management tools, task allocation tools, and most importantly, we're going to have a Git and GitHub demo at the end. But first things first, before we start, I don't know how many of you saw like the Slack channel update about like getting a GitHub account and getting it installed on your computer. It's totally okay if you don't have that. We can help you out later on. But if you do have a GitHub handle, put it in the chat. And then OCN or Neha can add it or add you to the GitHub repo. Just a question though, does anyone here not have GitHub? General silence. I shall take that as y'all have GitHub already. Okay, cool. So then just put your GitHub handles in the chat. In any case, we can get started then. Oh, so cool. Basically, the reason why we're having this whole presentation today is because of the unfortunate death of the lone coder idea. And by that, I just mean like, I'm sure you all have heard the stereotype of like, you know, that one person who sits in the back of the company and just like knows everything about the code base and like literally no one else in the company knows about that. And that used to be just like what everyone's idea of programming is. And now we call that like a super dysfunctional company, right? Like basically nobody does that anymore. Everyone, like code bases are so big that we need a ton of developers working on everything all at once. And like, just to give you some perspective on like how big code has grown like over time, we sent like for the space shuttle, we had like less than 1 million lines of code. And nowadays, like Microsoft Office is 25 to 50 million lines of code. And Google is like legit 2 billion lines of code. So that's like way too big for any one person to manage. So we know we need a lot of people, but you know, some problems arise when we have a lot of people working on the same thing at once. So what do we, like, I guess to demonstrate some of the issues that we might run into for, you know, such a setup, to demonstrate this, we're gonna do an activity real fast. So if you guys have like tablet stuff or things you use to draw, you might wanna grab that right now because we're about to do a drawing activity. Does everyone have that like nearby or does anyone need to run and grab that real fast? Yeah, you good? Okay, sweet. All right, basically, there are 2 rules. We have 1 minute. And secondly, everyone has to contribute something. So, you guys ready? Yes, maybe so? All right, cool. Well then, we have 1 minute to draw Starry Night plus doggos in the box on the right. Starting the timer now. Oh, and that's it. How do I turn it off? Okay, there you go. Cool. Wow, actually, that actually turned out kind of nice. Like, awesome. Wow, that actually like went pretty smoothly. I anticipated it being a little bit rougher, but that was rougher. Dog. Anyway, I'm gonna clear the screen then. But the thing that this was supposed to demonstrate was a few problems. I mean, aside from the fact that it's just like really fun to draw. But we were going to use this exercise to investigate like a couple things that we might have done like implicitly. But basically, there were some things that we had to like consider when we were doing this, right? There was like the high level or organization. So like identifying what needed to be done and then allocating who does what. We kind of did that silently and everyone just kind of claimed their half of the picture, just like, you know, on the fly, which is like pretty impressive. That usually doesn't happen so smoothly. But yeah, that's where like, those are some major problems that often come up in software development too. And then we also had like the simultaneous implementation. So just like, you know, everyone has making their own small contribution. And we were also trying to make it all look like the cohesive picture, which ended up pretty well for us. But you can imagine how difficult it might be for like giant code bases, like for everyone to be inserting like little bits of code and working on the same thing at once. So we're going to go over like these 2 general themes with the tools that we talk about today. All right, cool. So first things first, high level organization. I'm sure those of you who have taken like soft dev already, like 3308, you've probably heard of this and gone into probably more detail than you ever wanted to about Agile. So I'm going to leave it to soft dev to talk about that. Basically, for our purposes, we'll just know Agile as like a super popular way for people to manage their software development teams. And it's super popular because it's flexible, it's very fast paced, and they're really focused on the customer, which is a huge theme these days, as it should be. Um, and basically, the whole structure of Agile relies on a lot of communication and a lot of updates. And so the big problem arises, like, how do we organize all of that? Basically, the most popular method we use, or a popular method that we use, is Kanban boards and a lot of meetings, but it'd be very weird if we simulated meetings. So we're just going to go over Kanban boards. As you can see from this GIF, that's a Kanban board. We basically break down a large project into lots of little pieces. And those little pieces are those cards there that the cursor's dragging around and manipulating. These describe what needs to be done and kind of breaks everything out into like digestible pieces. And then, like for us when we were drawing that dog, like picture dogs plus starry nights, one of the tasks could have been like, I'll draw the doggo's face. And then someone else has like, I'll draw the sky and stuff like that. And those would be the cards. Then people get to assign themselves to tasks. Like I took it upon myself to draw the doggo's face on the left. And so in Kanban, I would just like mark that card as mine. And then basically we have different categories for just like how much work has been done so far. And so we basically drag cards along the further along we are with that task. And so at the end, ideally, all the tasks have been moved to the right end and shows that everything is done. I'm not sure if you can read that, but like that GIF there, they have the categories as to research, to do. I actually don't know what that middle one says, but the end says done. And that's kind of where we want all of our cards to go eventually. Yeah, just some examples of popular Kanban boards. We have Trello, Kanbanize, like LeanKit. There's also Jira, a lot of other popular ones. But anyway, it's just good to know about the concept. And that's how most people manage high-level stuff. So what about kind of the bulk of what we do as software developers, right? Simultaneous implementation. That's the tricky part, managing little bits of code kind of and trying to mush them all together into a cohesive picture. And that's what we call source code management, SCM. You'll see that acronym a lot just because source code management is so important these days. And it's basically just a way to help us organize and collaborate on code. So there are a lot of different source code management platforms and tools out there. I'm sure you've heard of a bunch of them so far, but they all do the same fundamental things, right? They check what changes have been made. They make sure no one sketchy is adding to your repository, right? You don't want just some person to be able to edit all of your code and have that integrated in your system. That would be super scary. And then we also have like asynchronous workflow tools, and we'll talk about that a bit more. But among all those tools, the ones we're going over today, as you guys know, is Git and GitHub. Quick note about these two things, they are different. I know they often come like in pairs, but there is actually nuance and they're two different bits of software. Git is the thing that's locally on your device that actually does all the source code management work. GitHub is the thing on the interwebs that actually like hosts the project and lets people collaborate on them, but it doesn't actually do the source code management work like Git does. So it's just a good thing to be aware of as we go through this. We're now at the demo part, so the exciting part. If I think you all said that you already have your GitHub accounts, so we don't need to worry about getting them all installed. And basically, we're now going to move on to our repository here. We're here. Let me share this link first. I'm sure you can, like, you guys can see this, right? Hopefully, okay, I see some nods. I'm gonna put the repository link in the chat. And cool. Should be able to open that up and see this. Is everyone here? Yeah? Okay. Cool. So what we're going to do is we're going to learn how to use Git and GitHub while helping out the UN World Food Program. So if you're curious how we're going to do that, we have the high level idea here. Basically, we're going to go to this site called FreeRice, which basically contributes free rice to the UN World Food Program. I say free rice with quotations because it's actually generating money through ads, and then they send that to World Food Program. But the essence is that that money will be used to buy free rice for folks who need it. So the idea is we're going to go to that website, we're going to play the game for however long we want, and then we're going to contribute that amount of rice and tally it all up so we can see what sort of how much Blueprint has contributed to the free rice cause in general. So first things first, we're going to need to install this code locally or download it. So what we're going to do is we're going to go to this green button here, and we're going to copy this link. You can also feel free to just copy this. It should be correct. And we will go to our terminal, which I realize you guys can't see here right now. Okay, I'm just going to share the desktop here so y'all can see my terminal. All right, so here we are. This is just where I want to store my repository. As you guys know, you can grab this command, but I'm just going to write it all out just to be clear. We're going to clone the repo, which means we're just going to nav it from GitHub and put it on our local computer. So that command is git clone. And what should happen is you should get this, these notifications. Is everyone with me? Sweet. All right, so now what we're going to do is we're going to go to FreeRice. I'm just going to copy this because I want to add a tab here. You can play in whatever language you feel most comfortable with. Basically, we can just play a few rounds and just keep track of how much rice we've generated. Okay, we're at 20. So I think we can proceed. I think they'll catch up pretty easily here, but we've got 20. So basically what we're going to do now is we're going to go inside that folder that we downloaded. If you do ls, you should be able to see that there's now a folder there. And now we're going to go into the folder using cd and then the name. Okay, well, cool. So now we're here. And now we're going to create a new branch. Basically, branches are a way for people to just make a copy of all of the code, work on things without stepping on other people's toes, and basically just work with the code without affecting anyone else. So what we're going to use is we're going to use this command here, git checkout -b. Don't use this branch name. It would be a pain to type out, but use something unique. Like here, I'm going to say, instead of your unique branch name, I'm going to say mtran. Man, I feel like I numbered them at this point and I can't remember which numbers I've used. I don't think I've used 3. We're going to go with 3. All right. Are you with me? Yeah. Git checkout -b makes a new branch. Now we are going to update ricetally.txt using our favorite editor. So we can open this up in whatever text editor, VS Code, whatever. I'm just going to use Vim because I don't want to leave the terminal. So here we have ricetally. I'm just going to do vim ricetally, etc. And we're here. Hello. Just going to add a new line here. You can also add a nice message if you want for anyone who's editing this in the future. 20. Yeah, I don't know what to say. What do people say to people that they don't know? I'm just going to say you're cool because they probably are if they're doing this. Okay, so once you add your line, just save that. And then we'll move on to the next step. Is everyone good? Very cool. Now we will do the Git stuff. So Git has a couple of phases that we have to go through. And the first thing we want to do is we want to let Git know which files we modified and want their changes to go into the modifications and commit chain. For us, it's really easy, right? We modified one file. The whole reason why they have Git add is if you modified a bunch of files, but you only want a couple of your files to show up for everyone to see. That's why you use Git add. I, for one, have definitely written some code and been like, ooh, I don't want anyone to see that for a while. So then I did not add it, like I didn't say git add for that one, that I'd add the rest of my changes. So what we're gonna do is we're gonna say, since I made changes to rice tally, you can see, I'll say git status. This is the one we modified. I'm gonna say, I want that modification to be in a queue for me to commit. Okay, and it doesn't give you a message afterwards, but it should go through okay. So everyone good at this one? You can, like, you specify what files you want to add using this command. And I said git add ricetally.txt because that's the specific file. There are other things you can do, like git add star, which means I want everything to be added, and etc. But here I have the name just because there's only one file that I want to change. You can add multiple files too, like just separated by a space. But since we modified one, there's no need. We will now like say these changes, like these changes that we specified, right? Nothing's been done with them. Git just says, okay, you want these changes to be saved eventually, but I haven't saved them yet. So committing is how we like actually save those changes to our source code, like tree. This is how we say, that's it, I'm officially gonna do this. So no turning back, just kidding. You can revert branches, but even still, the idea is to make it more finalized. So we're going to use this command here. The command is really git commit. The -m just says I want my command message or my commit message to be like done in this line. And I'm just going to say how many I added plus 20. And that should be good. It should let you know like what changes you made. Is everyone seeing that? We can now say that these changes, everything that we said and like committed, this is all still locally on our computer. It is not in GitHub yet. This is just all in the realm of Git. So now what we're going to do is we're going to push our changes, i.e. we're going to make them appear in GitHub instead of just locally on our device. The way we're going to do it is with this command. It's a little lengthy, so I'm going to try to explain them in like pretty simple terms, what each part means, but basically git push is the main command, right? That's the one that's saying, I want to push all these changes. This set upstream, like your unique branch name, you have to change this to whatever your branch name is called. Mine, as you can see, is mtran3. Yeah, yours will be whatever you decided to change the name to earlier in your git checkout command. But basically what I'm saying is this branch mtran3 doesn't actually exist in GitHub yet, right? When you see these branches, there's only one branch. What I'm saying is I want there to be a branch called mtran3 in GitHub, and I want it to have all the changes that I've made so far. So that's all you're going to say for that command. And you should get all of these happy notifications, etc. Is everyone getting that? If you're not sure whether you're getting it too, like I just pushed this, right? You'll know whether you have it or not if you go to GitHub and see, oh, well, would you look at that? So yeah, that's my branch. And then other people have their branches there. So this is good. You go to your branch. I'm going to go to mtran3, but you all go to your respective branch. And basically what we're going to do is we're going to, as we say here, we're going to click pull request. A pull request is just a way for you to say, hey, I made these changes. I want to make them official to our code base. And most people do that by making the main branch. The main branch is just a convention. It's just like any other branch, but it's the one that everyone says has like the full working code so far for the org. So I'm going to say I want to make a pull request. And you should see something like this. Does everyone see something like this? And so we see here base main. This is what says that we're going to put our thread or put our branch and merge it with the main stuff here. So what we're going to do is we're going to say create pull request. Ta-da! This green color is very nice. And basically what it says is we are A-okay. Because multiple of us, like we're all contributing stuff all at once, we might get conflicts. But for now, should be green. It should be okay since none of us have merged anything yet. So once we get here, you can like add descriptions if you really want to. I don't really feel like it. So I'm just going to click merge pull request and I'm going to confirm that merge. And then it should let you know that it's successfully merged and should turn purple in a very satisfying manner. Does everyone see that? It's probably because my modification is in the way now, right? Okay. I'm going to delete this branch. So the way we deal with that is you're probably going to have to get the most updated code. So let's go here. You might have to do this one at a time because that might be the most efficient way to do it. We could all like pull it multiple times, but that might not be ideal. And basically, to answer your question, Don, basically, this workshop was just like a bit of a taste test, right? But we have a ton of resources here if you're looking to learn more about Git. They have a bunch of like command sheets, and Oceane made her very own like blog post and like GitHub repo that goes even more in depth about all this stuff. So if you want to learn more advanced commands and stuff, definitely look into the resources that Git has online. They have a ton of them. Then Oceane's awesome workshop here is super good too. Would really recommend you check that out if you want to learn more.
I have a question, and I don't know if there's an answer, but so you mentioned earlier that you've used things other than GitHub. What were the other things you've used?
Yeah, I think one of the like they have some like GitHub knockoffs. Like they have like Git T. I think it's like a free enterprise version. They also have like Bitbucket. I don't know if y'all have heard of that, but Bitbucket basically does the same thing as Git or GitHub, but I guess different interface. But yeah, those are a couple things. I'm sure there are a bunch more, but I haven't used them personally.
Why did you use those versions then?
Because the people I was working for were using them. Like I always use Git, but like one of my internships, they're just like, we use Git T, don't ask. And I was like, okay. And then the other place just happened to use Bitbucket too. So I don't know why they used it, but.
Does it have something to do with the cost? Because I don't know how much.
Yeah, I think because GitHub has an enterprise version, but it costs money. So Git T, yeah, I think that's why at my internship they used Git T because it was free for companies. I don't know what Bitbucket's advantage is though. Seems like we're good, and it seems like everything is good and merged. So yeah, congrats y'all. Yeah, and good job. We have added more to our rice tally, and hopefully we can add more in the future.